I have the CCI indicator. I changed it to dots so that you can actually see these distance jumps here. So you can, so now we can actually see the distance between these plot points here, right, on the indicator. What the question really boils down to, the question, was asking, how do we identify the slope of the indicator? And then it also asks to identify, the distance moved by the indicator. What is this distance that's been moved? And that's what a slope is on a chart, right? You can't measure a slope on a chart in degrees, right? So right now, that looks about like 45 degrees, right? 45 degrees. Now, what happens if I do this? Well, now it looks more like 80 degrees, 75 degrees, right? So you can't measure in degrees. You can only measure in slope when you're charting. And to simplify it even further, a slope on a chart, the x-axis is always fixed. The x-axis moves from one bar to the next bar to the next bar, right? So your units of measurement from bar to bar is always one, right? One bar to the next bar. You can't move half a bar. You can't move 2/3 of a bar, right? So the x-axis is always fixed, has a fixed value of 1. So in charting, a slope always boils down to how far did your indicator move? What is that distance movement? That is the slope on charts. That's what it always boils down to, right? So measuring that distance is also telling you the slope of that indicator, right? It's one and the same when it comes to charting. So that's what we're going to do there is identify when the distance moved on the CCI is greater than 100, right? And so therefore, that creates a slope of the indicator, a slope that's greater than 100 as well. Let's switch over to the logic tab here, right? And we can start working on the logic board here. All right, so that's what we're going to find is a minimum, movement of 100, as, this could just, again, slope and distance moved are one and the same when it comes to charting. So we're going to go to our solvers node, and we're going to use the comparison solver to figure this out. We could use the slope solver as well, I believe. Yeah, you know what? Maybe the slope solver is a little simpler to use. We'll go with the slope solver because that's a little simpler to set up because the slope solver only has one input, right? We only have to put the CCI indicator, plug it into the slope solver one time, whereas if we use the comparison solver, right, with the comparison solver, we have input A and we have input B. So we would have to plug the CCI into the comparison solver twice, which is not hard, but but the slope solver does kind of simplify it a little bit. So there. All right. And I'm also going to delete that comparison solver there. Let me get rid of it there. Okay. So with the slope solver, let's give this a name. So we're looking at the CCI slope, and maybe you might want to put the period setting in there. So CCI 14 slope. So, all right. So next step is let's change our indicator here from the SMA to the CCI. All right, there's the CCI, and I'll just use the default period there. Click OK. All right. So we are looking for a slope of 100. So we're going to put that in twice, right? We're going to put 100 in for the maximum and the minimum slope there. Now, the CCI indicator, right, it runs on its own scaling, right? It runs in its own subpanel. right? And it has a scaling, it has its own scaling, so to speak, right? So indicators such as the MACD, the CCI, the stochastics, right? They all run in their own subpanel, and they all have their own scaling. So when you're using indicators that have their own scaling, there is no such thing as ticks, right? Ticks do not apply to those indicators. Ticks only apply to the price panel. So ticks, the measurement unit of ticks is only valid for indicators that are designed to run on the price panel, right? If an indicator runs in its own subpanel, then it's not moving in ticks. So we need to change that measurement unit here, right? So if you expand expand each of these settings open here, you can change the measurement unit. So we need to go from ticks to points, right? And again, technically, right, the CCI indicator doesn't move in points, but the scaling, the scaling of the CCI, for all intents and purposes, is from one point to the other point, right? So, even on the price panel, points on the price panel is the main measurement unit, right? It's the primary measurement unit is points on the price panel. And so for indicators, points is also the primary measurement unit to go from one value to the next value, right? So you want to change your measurement units to points for the CCI and other indicators like the MACD and the stochastics, right? Or the ADX, the ADX indicator, things like that. So, all right. So we're looking for a minimum slope of 100 points, and basically we're done. That's it. So the slope solver is doing, basically all the work there for us. And so now we can see, right, whenever the CCI moves greater than 100 points, we're going to get either a short signal for a movement down, or we will get a long signal for movements upward, like so. And that's it. So since this was so simple to answer, probably the next follow-up question would be, well, what if I want to isolate these signals so that they only occur on the quote correct side of the zero line? So for example, right, we have this long signal, but the CCI is a negative number, right? It's below the zero line. So what if you only wanted to see long signals when the CCI is above the zero line, right? Or maybe you're building a counter trend signal, in which case you would only want to see long signals below the zero line, right? So if you wanted to kind of add in that secondary requirement to this, then that would be a matter of grabbing a comparison solver. A threshold solver there. We could do it in the comparison solver, but technically speaking, the threshold solver is the correct one to do it with, right? Because with the CCI, the CCI indicator specifically, built for looking for different threshold levels, right? The CCI has the 200 threshold level, the 100 threshold level, the 0 threshold line, the negative 100 threshold line, right? So all these lines are threshold levels for the CCI indicator, right? So that's why this is called the threshold solver. So if you're looking for long signals, only above the zero line, then you would grab the threshold solver here, and let's plug in. Actually, let's give this a name first. All right, so we're comparing the CCI to the 0 line there. So now let's plug in our CCI indicator. All right, there it is. And again, we're just going to use the default 14 period. Click OK. And so our threshold values here are all set to 0, so we're just going to leave them at 0. And so if we are looking for, right, a long signal, you know, greater than 0, then this is what we want, right? Greater than A. What is A? A equals to 0. So we're going to put a 1 in there. And for the short outputs, we're going to put a 1 in less than E, right? E equals the 0 line threshold value. And so basically we can see now on the chart, whenever the CCI is below the 0 line, we're getting a short. And whenever the CCI is above the 0 line, we're getting a long output. And so now we just need to combine these two solvers together, right? So we're going to use an AND node. All right, so once again, let's keep an eye on this. Oh, here we go. So actually here is two good examples here, right? So there, so we have a long signal there. And we have a long signal there, right? So we can see this one, this long signal, the CCI is above the 0 line, but over here the CCI is just barely below the 0 line, but it is. So as soon as we connect in our threshold solver, right, it's going to filter things out for us. So there we go. This long signal has now disappeared. Right. So there we go. There's a little extra added step thrown in. So this is usually the next logical question that comes up when people ask this question, you know, which is filtering your signals at some kind of threshold level for the CCI, you know, and that's how you would do it. So